The Geosense Wi-SOS 480 wireless sensor network is used extensively within geotechnical and structural monitoring. Here we show how signal strength tests can be carried out prior to installation to help engineers confirm the suitability of a wireless network. Transport for London is planning a major upgrade of the Bank Monument Station complex. Set in the heart of London's financial district, Bank is one of the largest and most complex underground railway stations in the world, and this will be one of London's most complex infrastructure schemes. Instrumentation and monitoring will be a key factor, as tunnelling will take place under iconic landmarks such as the Bank of England and Mansion House. It is likely that monitoring will be required at 8 different locations. It is a congested urban area with many high-rise buildings covering approximately 2 square kilometres. All the data from instruments including borehole rod extensometers, piezometers, tilt sensors and inclinometers needs to be connected into a central data logging system to provide real-time monitoring during construction. Running cables from the sensors to the data logger along busy London streets is not considered a viable option, and so a wireless system was seen as the best solution. The Wi-SOS 480 uses the Worldsensing G6 Platform. It is a long-range wireless system with high connectivity, low power consumption and low costs. Spread spectrum technology spreads the narrow band signal across varied frequencies, making it more resilient to interference and using less power. An important feature of the Wi-SOS 480 is the ability to carry out signal coverage tests prior to installation. Measuring the spreading factor between the node and the gateway confirms successful data transmission. To carry out the test, we use the Wi-SOS 480 signal coverage test kit, which comprises a gateway, a node, and an Android tablet. The data is modulated, and a reading on any one of the 6 spreading factors shown here signifies successful data transmission. We begin by setting up the gateway in the client's office. It's in the large building on the right. As expected, perfect results 500 metres down the road. A busy junction and another test, now about 900 metres from the office. Still full coverage. Another test, this time near the monument landmark, and still perfect readings. Further along the road towards the Thames, to the furthest point at which sensors will be installed, and still full coverage. Lastly, a final reading outside Cannon Street Station at the other end of the project, and perfect readings. Returning to the contractor's office, the signal coverage test is now viewed on the Wi-SOS Web Centre. The spread factor strengths are viewed and success verified. A real-time map of the project and surrounding area shows the locations and signal strengths of the individual nodes. A full-strength signal from every location, and all completed in less than 2 hours. This means the instrumentation engineer can complete the monitoring plan confident that a wireless network system using the Wi-SOS 480 is a realistic solution. Wi-SOS 480, it's what the instrumentation and monitoring industry has been waiting for.